So this category of variable star, this category of explosion, has come to be known as nova.
Get ready, because the cosmos is about to put on a show like never before. The star Antares is on the brink of a massive explosion, and when it happens, it could outshine even the full moon. If you love stargazing, this is an event you won't want to miss. This supernova will be one of the brightest celestial events in human history, visible even during the daytime. But when will it happen? How will it change our view of the night sky? And what does this mean for the future of space exploration? Let's take a closer look at the science behind the Antares explosion and why astronomers are calling this a once-in-a-lifetime event, the imminent explosion of Antares. A supernova is when a star explodes, and it's one of the biggest explosions of radio energy in the entire universe. The night sky is in for a big change as Antares, a red supergiant 700 times bigger than our Sun, nears the end of its life. This massive star is set to explode in a way that could outshine entire galaxies, possibly becoming brighter than our whole Milky Way. Supernovae within our galaxy are super rare. The last recorded one happened centuries ago, so the explosion of Antares will be a once-in-a-lifetime event. For astronomers and space fans alike, it offers a rare opportunity to see cosmic history unfold. The explosion will impact the galaxy in ways we can't even imagine. Antares is a true giant of the night sky, located around 604 light-years away from Earth. This red supergiant has a diameter of about 700 times that of our Sun. To picture that, if Antares were placed at the center of our solar system, its surface would stretch all the way past Mars. It's also one of the brightest stars in the sky, fluctuating between 0.88 and 1.16 in apparent magnitude, though these changes are subtle to us. This fluctuation is a sign of the star's dynamic nature. When Antares reaches the end of its nuclear fuel, it will undergo a spectacular collapse. As its core runs out of hydrogen and helium, heavier elements such as iron will form. This buildup prevents further fusion, causing the core to collapse under its own immense gravitational pressure. Within seconds, this collapse will trigger an uncontrollable explosion, a supernova. The resulting explosion will release an immense burst of energy, making Antares temporarily as bright as an entire galaxy. The explosion will send out powerful shockwaves and radiation, dispersing heavy elements such as gold, silver, and uranium across the cosmos. These elements will eventually become part of new star systems, planets, and even the building blocks of life. The name Antares itself holds meaning. In ancient Greek, it means rival of Mars, given its red hue, which closely resembles the red planet. Ancient astronomers noticed this resemblance, and the star became a significant part of their stories and navigation methods.
Red stars, of which there are many, in every galaxy. All right. But there's no gas in the elliptical galaxies. There's no fresh generation to be made.
The link between Antares and Mars reflects humanity's tendency to find patterns in the stars and connect them to our own lives. What is a supernova? Now, let's break down what actually happens during a supernova. This explosive event occurs when a star runs out of fuel and can no longer support its own weight. The star collapses, causing a massive explosion that releases an enormous amount of energy. Supernovae are so bright they can even be seen during the day. The expelled material travels at speeds nearing 30 million miles per hour, creating shockwaves that ripple through the universe for years. The explosion's heat and pressure forge elements heavier than iron, such as gold, silver, and uranium, which are then scattered across space. This process enriches the interstellar medium with the building blocks for new stars, planets, and even life itself. Supernovae play a key role in the cosmic ecosystem by creating and distributing the elements necessary for life. The aftermath of a supernova can go two ways. It can result in a neutron star or a black hole.
Well, it's a little supermassive black hole. So it's about 6 million times the mass of the Sun.
Neutron stars are incredibly dense, with a mass comparable to that of the Sun, but compressed into a sphere the size of a city. Their gravity is so strong that even a teaspoon of material would weigh billions of tons. Black holes, on the other hand, have gravity so powerful that not even light can escape. Binary systems and stellar evolution. The study of binary systems helps scientists understand stellar evolution. These systems, like Antares and Antares B, are complex and can shape the fate of stars. The interaction between two stars in a binary system can affect their aging process, mass loss, and even how they explode in the end. Another interesting binary system on the brink of a dramatic explosion is T Corona Borealis.
In the northern hemisphere, we have Corona Borealis, and one of the stars in that constellation varies in brightness.
This system consists of a red giant and a white dwarf, and it's predicted to explode into a nova soon. A nova is less powerful than a supernova, but it's still a remarkable event. The upcoming nova from T Corona Borealis will be visible to the naked eye, providing a rare chance to witness a stellar explosion in real time.
Guess the date correctly, we know that this nova should definitely occur. And there is a really good reason why we think so.
The last recorded supernova in the Milky Way was in 1604, documented by Johannes Kepler. Known as Kepler's supernova, it was visible to the naked eye for over a year and rivaled the brightness of Mars at its peak. Since then, our galaxy has been quiet, at least from our perspective. This makes the potential explosion of Antares particularly significant. If it were to go supernova in our lifetime, it would provide an unprecedented opportunity for scientific study and public engagement with astronomy. The explosion would offer unique insights into the final stages of a massive star's life. Despite the rarity of observable supernovae in our galaxy, modern technology has revolutionized our ability to detect and study these events. Advanced telescopes and detection methods allow astronomers to observe supernovae in distant galaxies, expanding our understanding of these cosmic phenomena. These advancements provide astronomers with new ways to study supernovae across vast distances and refine models of stellar evolution and explosion mechanisms. Antares and its potential. Supernova. If Antares were to explode, astronomers would be able to follow the entire sequence of events in detail, something that has never been done with a supernova in our own galaxy, using modern technology. The study of Antares' final moments would allow scientists to observe how its brightness fluctuates and how its temperature and chemical composition evolve over time. By analyzing these changes, researchers could confirm existing models of stellar collapse and improve our understanding of the precise triggers behind supernova explosions.
Oh, by the way, in the distant future, as we continue to expand, galaxies will expand beyond.
The explosion of a massive star like Antares would also provide insights into what happens in the moments leading up to a supernova event. The final collapse occurs when the star's core runs out of fuel, causing it to collapse under its own gravitational force. If the core is large enough, the resulting explosion could either leave behind a neutron star or a black hole.
But wait, there's more. There's the matter of the black holes.
Okay.
A transformation that remains one of the most mysterious and poorly understood processes in astrophysics. With modern telescopes and space observatories like Hubble, James Webb, and Chandra, scientists could track every stage of Antares' explosion, from the initial collapse to the formation of its remnant, allowing them to refine models of how stars evolve and die. Beyond the spectacle of a supernova, the explosion of Antares would provide crucial data on the production and distribution of heavy elements in the universe. Supernovae act as cosmic forges, creating elements heavier than iron, such as gold, platinum, and uranium, and dispersing them throughout space. These elements eventually seed new generations of stars, planets, and even life itself. However, unlike some supernovae that pose potential threats to Earth, Antares is far enough away that its explosion wouldn't have any harmful effects on our planet. Instead, we would be able to observe it safely from a distance, benefiting from the scientific insights it provides without worrying about damaging radiation or other cosmic hazards. Proxima B. Proxima B is our closest exoplanet neighbor, orbits the star Proxima Centauri, just 4.2 light-years away from Earth. Its proximity makes it a prime target for scientific study and exploration. Recent measurements suggest that Proxima B is more Earth-like than previously thought, with a mass 17% greater than Earth's. It orbits its star in just 11.2 Earth days, indicating its close proximity to Proxima Centauri.
James Webb hasn't even attempted an observation of Proxima B, let alone discovered anything there.
One of the most exciting aspects of Proxima B is its location within the habitable zone of its star, where liquid water could potentially exist. This raises the tantalizing possibility that Proxima B could support life, fueling dreams of discovering life beyond our solar system. Despite its Earth-like qualities, Proxima B's environment presents significant challenges. Proxima Centauri, a red dwarf star, emits intense radiation that could prevent Proxima B from retaining an atmosphere. Without a protective atmosphere, the planet's surface could be exposed to harmful stellar radiation, making it inhospitable to life as we know it. The proximity of Proxima B to its star creates a precarious balance. While it resides within the habitable zone, the intense radiation from Proxima Centauri poses a significant threat to its habitability. This tension between hope and adversity highlights the complexities of exoplanet research. As we continue to study exoplanets like Proxima B, we gain deeper insights into the possibilities for life beyond Earth. Advancements in technology, such as the James Webb Space Telescope, provide clearer images and more detailed data, bringing us closer to answering fundamental questions about the potential for extraterrestrial life. The study of Proxima B and similar exoplanets represents the next frontier in our understanding of the universe. With each new discovery, we inch closer to unraveling the mysteries of distant worlds and our place in the cosmos. Tidal locking and extreme temperatures. Proxima B's close orbit means it's likely tidally locked, meaning one side of the planet always faces the star, while the other is in perpetual darkness. The consequences are severe. One hemisphere could be scorched by constant daylight, while the other remains frozen in eternal night. Between these extremes lies a narrow band, the Terminator line, where conditions might be more temperate. This twilight zone is one of the few areas where life could potentially exist, but the extreme temperature variation across the planet makes habitability uncertain. Being so close to its star exposes Proxima B to intense radiation. Despite their smaller size, red dwarfs can be incredibly active, prone to massive flares that can be hazardous for any nearby planet. In April 2021, Proxima Centauri emitted a flare 100 times stronger than any from our Sun, highlighting the volatile nature of its environment. These flares can strip away a planet's atmosphere over time, leaving it exposed to harmful radiation. Additionally, Proxima Centauri's powerful magnetic fields contribute to this chaotic radiation environment, further complicating life's potential on Proxima B. The combination of intense radiation and extreme temperature fluctuations makes it hard to imagine life surviving on Proxima B. With solar wind radiation 1,000 times greater than Earth's, most known life forms wouldn't be able to withstand such an environment without specialized shelter. However, this doesn't rule out the possibility of life altogether. Life might exist in forms unimaginable to us, adapted to these extreme conditions, pushing the boundaries of what we consider habitable. Despite the harsh conditions on Proxima B, its position within the habitable zone of Proxima Centauri still fuels optimism. With a rocky composition and the potential for liquid water, Proxima B might support life under the right conditions. However, its close proximity to Proxima Centauri exposes it to dangerous radiation that could strip away its atmosphere over time. The discovery of a mysterious signal from the Alpha Centauri system in 2021 has reignited interest in the possibility of intelligent life in our cosmic backyard. Although some suggest it could be a sign of extraterrestrial intelligence, the discovery also serves as a reminder of the potential for groundbreaking discoveries as we continue our exploration of nearby star systems like Proxima Centauri. Buzz Aldrin's opinion. Buzz Aldrin is one of the few men to have walked on the moon and offers unique insights into space exploration.
Behavior of our moving around on the surface.
He helped land Apollo 11 on the moon and also planted the American flag, conducted scientific experiments, and even took time for a personal spiritual moment. His description of the moon as
100,000 years, it's the same, just gray. I don't want to talk about how many different
magnificent desolation paints the perfect picture of the moon's beauty and emptiness. But Aldrin's contributions go beyond the mission itself. Aldrin has also sparked intrigue with his comments about the far side of the moon, suggesting there could be hidden structures or evidence of extraterrestrial activity. These ideas have fueled speculation and theories, but we must remember that much of what we see in lunar images
did have the camera from taking pictures of something else. I decided, well, now's the time.
Could be the result of our brains looking for patterns where none exist. Even so, Aldrin's curiosity about the moon's far side has ignited a renewed interest in exploring this mysterious part of the moon. During Apollo 11, Aldrin witnessed an object in space that he couldn't identify, sparking conversation about the possibility of extraterrestrial life. The object appeared to move in a controlled way, not like space debris. Aldrin has been transparent about this experience, leaving room for speculation without jumping to conclusions. The sighting raises fascinating questions about what might be out there, contributing to the mystery of space exploration. Aldrin's perspective on extraterrestrial life is grounded in the vastness of the universe. With billions of stars and planets, it seems almost impossible that Earth is the only place with life. He advocates for continued space exploration, urging humanity to keep pushing the boundaries of what we know.
Earth orbit to lunar orbit and back and forth.
The idea that we might one day encounter life beyond Earth is an exciting prospect that could transform our understanding of the universe. The moon, with its extreme conditions, seems like an unlikely place for life. However, there are theories that life could reach the moon via asteroids or even human missions. In 2019, a spacecraft carrying microscopic tardigrades crashed on the moon, sparking speculation that these resilient organisms might be surviving there today. While there's no evidence of a thriving ecosystem, the possibility of life on the moon raises intriguing questions about space travel and the survival of life in extreme environments. James Webb Space Telescope. The James Webb Space Telescope offers powerful tools for studying distant exoplanets, and its ability to detect transiting planets is key in identifying elements that might hint at habitable conditions or even the presence of life. One of the crucial instruments on the JWWST is the Mid-Infrared Instrument, MIRI, which extends the telescope's vision into the infrared spectrum. This is essential for studying cooler celestial objects, as it allows scientists to examine the thermal characteristics of exoplanets, giving insights into their surface temperatures and conditions that are vital for assessing habitability. Another important tool is the Near-Infrared Spectrograph, NIR-SPEC, which enables astronomers to analyze the chemical makeup of an exoplanet's atmosphere. It works by dispersing light into a spectrum, allowing the detection of key molecules like water vapor, methane, and other organic compounds. These elements provide clues about the potential for life, making the JWST an invaluable asset in the quest to explore exoplanets in greater depth. Discovery of Gliese 163c. The discovery of Gliese 163c by the JWST made headlines, marking a significant step forward in our search for potentially habitable exoplanets. Located about 49 light-years away in the constellation Dorado, Gliese 163c is a prime candidate for life beyond Earth. Using the JWST's advanced instruments, scientists detected chemical signatures and thermal properties that suggest Gliese 163c lies within its star's habitable zone, the region where conditions could support liquid water, a crucial ingredient for life as we know it. Initial observations of Gliese 163c revealed its potential to support life, as it orbits its star at the right distance to allow liquid water to exist. The spectral data also suggested the presence of an atmosphere, another critical factor in assessing habitability. This discovery lays the foundation for further research, making Gliese 163c a top target in the search for life beyond Earth. Gliese 163c stands out due to its position in the habitable zone of its star, Gliese 163. This puts it at a distance where liquid water could potentially exist. The planet is about 6.9 times the mass of Earth, classifying it as a super-Earth. This suggests a rocky composition and a thicker atmosphere, which could create a greenhouse effect and warm the planet. The planet completes an orbit around its star every 26 Earth days, indicating it's much closer to its star than Earth is to the Sun. However, because Gliese 163 is a red dwarf, cooler than our Sun, this proximity places the planet in the ideal range for temperate conditions. The JWST's groundbreaking discovery of Gliese 163c is made possible by its advanced technology. Key instruments, such as the near-infrared camera, NIRCam, provide high-resolution images that reveal distant stars and their orbiting planets with incredible clarity. This allows scientists to detect minute changes in brightness and position, suggesting the presence of exoplanets. Interpreting the data from Gliese 163c involves complex computational models that help determine its atmospheric composition, surface temperature, and potential for liquid water. To ensure accuracy, these findings undergo a peer review process where independent teams of scientists validate the results. By using these rigorous methods, astronomers gain a deeper understanding of Gliese 163c, which aids in broader efforts to identify habitable exoplanets across the galaxy. What this discovery means. The discovery of Gliese 163c as a potentially habitable planet has significant scientific and philosophical implications. Scientifically, it challenges our understanding of planetary environments and pushes the boundaries of how we study planetary habitability. This discovery encourages the development of more sophisticated models to predict the potential for life-supporting conditions on distant exoplanets. Philosophically, it raises profound questions about humanity's place in the universe. The idea of another potentially habitable planet suggests that life beyond Earth might be possible, fundamentally altering our understanding of life's rarity and uniqueness. Building on the discovery of Gliese 163c, future missions aim to explore the planet in greater detail. These missions will focus on analyzing the planet's atmosphere, looking for signs of biological activity through gases like oxygen and methane. Scientists will also study its temperature gradients and seasonal variations to better understand its climate systems and determine whether liquid water could exist on the surface. Advanced spectroscopy and imaging techniques will offer high-resolution data, helping to map the planet's surface and weather patterns. Additionally, researchers plan to determine the planet's mass with greater precision, which will provide insights into its gravitational pull and potential effects on its atmosphere. Each new piece of data brings us closer to answering whether Gliese 163c could be a second home for humanity, or perhaps already host life of its own. Discovery of black holes. When further investigation of X-rays revealed that they weren't just being emitted, but were being pulled into an invisible object, it led to the discovery of a black hole. This breakthrough provided the first concrete evidence supporting Einstein's theoretical predictions, confirming the existence of black holes. Cygnus X1, in particular, exhibited some mind-blowing features: a luminosity 14 times greater than our Sun, and a gravitational pull so strong that not even light could escape. Hence, it earned its invisible title. This force reshapes the fabric of reality, showing that black holes are more than just cosmic vacuums. They're intense gravitational forces that stretch the very nature of existence. A black hole's structure is complex, with several distinct layers, each contributing to its enigmatic behavior. The outermost layer is the event horizon, the point of no return. This boundary defines the visible outline of a black hole. As you move inward, you encounter the photon sphere, where light becomes trapped in orbits around the black hole, creating a mesmerizing loop of light. Finally, at the core lies the singularity, where gravity is infinitely strong and matter is crushed to infinite density. This layer challenges everything we know about physics, and current theories break down when attempting to explain what happens here. Every layer provides a unique opportunity to test the limits of our understanding of the universe. The dangers of black holes. While black holes are fascinating, they are also incredibly dangerous. Their immense gravitational pull ensures that once something crosses the event horizon, it's trapped. This leads to the concept of spaghettification, where an object or person is stretched like spaghetti due to the difference in gravitational force acting on different parts of the body. The dangers extend beyond the immediate destruction of objects, as black holes can disrupt entire stellar environments. They accumulate gas, dust, and debris, forming an accretion disk that emits powerful jets, reshaping their cosmic surroundings. A major breakthrough occurred when scientists captured the first clear images of a black hole, particularly the one in the M87 galaxy. These images revealed more than expected, showing how matter and light behave around such intense gravitational forces. This has allowed researchers to study accretion processes and powerful jets of energy extending thousands of light years. The ability to visually observe these phenomena has provided new insights, transforming our theoretical knowledge into observable facts. Studying black holes presents unique challenges.
Together and then almost immediately blow up into huge black holes.
Since they don't emit light, researchers can't observe them directly. Instead, they rely on indirect methods, like studying the gravitational effects black holes have on nearby stars. Superstring theory adds another layer of complexity, proposing the existence of dimensions beyond the ones we experience. These extra dimensions may be compact and beyond our current ability to observe, complicating empirical validation. Furthermore, the instability of wormholes makes it difficult to study or confirm their existence, leaving much of our understanding of black holes speculative. The journey to Mars. As we push the boundaries of space exploration, Mars has emerged as the next significant milestone for humanity. With NASA's Perseverance and Curiosity rovers, we've made strides in understanding the red planet's geology and potential for life. Mars offers a stepping stone for humanity's expansion into the cosmos, but the road to Mars is paved with challenges, both technical and political, as nations and private companies race to establish a human presence there. Mars has captivated space explorers for decades, with the Soviet Union leading the charge during the Cold War. Their Mars missions in the 1970s made historic achievements, though many were shrouded in secrecy. For instance, Mars 3 was the first spacecraft to land on Mars, but the communication failed shortly after landing. The USSR's covert efforts marked a bold chapter in the space race, and though their successes were understated, they pushed the limits of space exploration during the height of the Cold War. Looking ahead, the future of space exploration extends far beyond Mars. The discovery of exoplanets in habitable zones around distant stars offers new opportunities for exploration and potential colonization. Visionaries like Elon Musk and private companies like SpaceX are fueling the dream of interstellar travel, while nations continue to work together to push humanity's reach into the unknown, the mystery of Betelgeuse. As we look to the stars, we are reminded of the impermanence of the universe. One of the most striking examples is Betelgeuse, a red supergiant star nearing the end of its life. Known for its brilliant ruby-red color, Betelgeuse's eventual supernova could be seen as a bright new star in the night sky. While we don't know exactly when it will explode, the fact that we are witnessing this cosmic event in real time adds a sense of urgency to our quest to explore and understand the universe before such events unfold. When Betelgeuse runs out of nuclear fuel, it will eventually collapse under its own gravity, leading to an explosion that sheds its outer layers. This event will briefly outshine entire galaxies, marking a spectacular end to Betelgeuse's life cycle. The explosion is known as a supernova, and also seeds the universe with heavier elements, contributing to the creation of new stars and planets. By studying this event, astronomers gain unique insights into the dynamic processes of star evolution. Despite the dazzling nature of Betelgeuse's eventual supernova, Earth is not in danger. Positioned between 430 and 724 light-years away, Betelgeuse is far enough to ensure no catastrophic impact on our planet. For a supernova to pose a real threat, it must be within 50 light-years of Earth. Even if cosmic radiation and energetic particles from such an explosion reach Earth, they would likely disperse or be absorbed by the interstellar medium before affecting our biosphere. Nonetheless, the event would be a spectacular sight, visible during the day, offering a once-in-a-lifetime opportunity for scientific research. The role of red supergiants in galactic evolution. Red supergiants like Betelgeuse are essential to the universe's evolution. As these massive stars reach the end of their lives, they undergo intricate processes that release heavy elements into the galaxy. These elements, such as iron, are crucial for the formation of new planets and stars. When a red supergiant explodes in a supernova, it scatters these elements across space, enriching the interstellar medium and contributing to the formation of new celestial bodies. The shockwaves from these explosions can even trigger the birth of new stars and influence the structure of galaxies, making the death of red supergiants a key factor in galaxy evolution. The future of astronomical observations looks promising, especially with next-generation telescopes like NASA's James Webb Space Telescope. These advanced instruments will significantly enhance our understanding of red supergiants like Betelgeuse, offering unprecedented insights into their behavior as they approach supernovae. The James Webb Space Telescope outperforms previous telescopes in resolution and sensitivity, allowing scientists to observe the star's outer layers, brightness variations, and surrounding nebula with remarkable detail. What's beyond the observable universe? While the observable universe spans 93 billion light-years, the question remains, what exists beyond this boundary? One theory suggests the universe might be infinite, with no true edge, extending endlessly and containing an infinite number of galaxies. Another theory posits that the universe is finite but without edges. Much like the surface of a sphere, if you traveled far enough, you'd eventually return to your starting point. Both ideas challenge our understanding of the cosmos and highlight its extraordinary complexity. JWST has already begun reshaping our understanding of the cosmos with its remarkable discoveries. Among the most stunning are 6 massive galaxies, observed to exist between 500 million and 700 million years after the Big Bang. Scientists expected to find only small galaxies at this early stage, so these mature, large galaxies pose a challenge to existing models of galaxy formation. These galaxies, comparable in mass to our Milky Way, suggest that galaxies may develop much more rapidly than previously thought, forcing astronomers to rethink the process of galaxy formation in the early universe. The future of cosmic exploration. The future of space exploration is incredibly bright, especially with the upcoming launch of the Nancy Grace Roman Space Telescope. Scheduled for 2027, this telescope will carry forward the legacy of JWST by exploring the mysteries of dark energy, exoplanets, and infrared astrophysics. With a mirror diameter identical to the Hubble Space Telescope, the Roman Space Telescope will provide a wider field of view, allowing for unprecedented sky surveys. Its coronagraph instrument will help observe faint objects like exoplanets by blocking out the glare of stars, revolutionizing our ability to study planetary formation and habitability. By building on the discoveries of JWST, the Roman Space Telescope will bring us closer to answering some of the most profound questions about the universe, including dark energy and the potential for life beyond Earth. As we move further into the future, the possibilities for discovery seem limitless, with the potential for new astronomical breakthroughs just around the corner. And that's it for Antares. What do you think? Will it be as amazing as they say? Either way, the sky's about to get a lot more exciting. Keep watching, and we'll catch you next time for more cosmic fun.